Hello, my name is Jim Olson, and this is a video on my inscribed circles activity. It's called Handout number 2, and this is part of the activities that I have prepared to help students learn mathematical reasoning through geometric problem solving. Let's jump right over to the handout. Okay. So every triangle has an inscribed circle, and here's an example of an inscribed circle. Here's an example of an inscribed circle, and so on. The three sides of the triangle are tangent to the inscribed circle. The center of the inscribed circle is the intersection of the angle bisectors of the angles. So if I would make the angle bisectors here, they would meet at the center of this circle. And I'll have you think about why that is true. There are a couple of important, powerful ideas that work with inscribed circles and also with many other problems in geometry. First of all, from a point in the exterior of a circle, the two tangent segments are congruent. So in this particular diagram, if we have this circle and we have this point out here and we have two tangents coming from that, this distance to the point of tangency is the same as this distance to this point of tangency. Same thing here, same thing here. Secondly, the relationship between a radius and the tangent line. Each radius drawn to the point of tangency is perpendicular to the tangent line. So if we had the center of the inscribed circle here and drew the radius, this radius would be perpendicular to the tangent line, and we'll see that when we do our example. The technique that we're emphasizing here in this particular handout is oftentimes we want to embellish a diagram by adding in segments. In the case of circles, we almost always want to add in radii. All the radii are congruent and they're perpendicular to the tangents. And when we have perpendicularity, we have right angles, which means we can use the Pythagorean theorem and other relationships. The other key method here to think about is symmetry. Consider reflection symmetry or rotation symmetry. So let's look at the first example here. We have a circle inscribed in triangle ABC. AB is 6. AC is 6 and BC is 4. What is the radius of the circle? And we have this diagram given. Well, the first thing to do in all problem solving is to understand the problem. Well, the diagram doesn't have A, B, and C on it. Where do A, B, and C need to be? Well, two sides are apparently the same length, so it's an isosceles triangle, and then we have a shorter side. So apparently point A is up here, and these 2 points down here are B and C, and I don't think it matters which one we label, so I'll do it like this. And we want to find the radius of the circle. And it seems nice to have a radius here, here, and okay. So we have 6 on this side. We have 6 on this side. And down here we have 4. And here's the first place we're going to use our symmetry. This angle is congruent to this angle because we have the isosceles triangle. So these segments are all going to be congruent. which means this point right here is a midpoint. Maybe I'll label it M, which means this is 2 on this side and this is 2 on this side. Okay, so you might pause the video and see if you can solve this yourself. The first thing I'm going to do is draw a line right down the middle. This is going to make this nice and symmetrical with 2 right triangles. So let me draw that perpendicular down the middle. All right, now what can we do? Well, by symmetry, this left-hand triangle is congruent to this right-hand triangle, which means we have a right angle here. And I have 2 sides of my right triangle, which means I can use my Pythagorean theorem. Let's do that. So set up the Pythagorean theorem. Once again, pause the video if you can to try to set this ahead of the professor. 2 squared plus am squared is equal to 6 squared. And work that out. So am squared is 32. So am is going to be the square root of 32. That gives us some additional information. Okay, now let's get the radii drawn in here. So let's draw in a radius here. And we're going to have one over here too. I don't know if I actually need it, but if kind of for symmetry, it might be nice to have it there. And that's perpendicular. So I'll call these radii R. All radii are congruent. Once again, pause the video if you wish and try to figure out what to do next. Okay, now it's oftentimes the case we would like to use different right triangles and maybe do the Pythagorean theorem twice. So this right here was for triangle AMC, triangle AMC. Now I would like to do the Pythagorean theorem on triangle A, I'll call this maybe ON, triangle AON. So I have a leg here, a leg here. Okay, now let's see what this is. Because these 2 tangents are from the same point in the exterior, this is 2 and makes this 4. So I do know AN is 4. So leg squared plus leg squared is equal to the hypotenuse. Now, what's the hypotenuse? The entire AM we found to be root 32, but I'm going to be subtracting R so that I get AO. So it's going to be root 32 minus R. There's the Pythagorean theorem. And now, once again, pause the video and see if you can complete that. On this right-hand side, when you have 2 terms in parentheses and you're squaring it, you need to have a good method for doing that, whatever your method is. What I like to do is square the first term, double the product, and square the second term. A negative R squared is going to be positive R squared. This is nice because the R squareds cancel out. If I subtract 16 from both sides, I get 16 on the right-hand side. And if I subtract or add a positive 2R root 32 to both sides, I get positive 2R root 32 over here. And now dividing by 2 root 32. 16 divided by 2 is going to be 8. Divided by root 32. Now we could simplify root 32 if need be. take out the perfect square and rationalize the denominator and so on, but the directions didn't say that we needed to do that, and the directions didn't say we needed to round it off. So I think I'm going to leave the answer that way, unless my teacher requires me to do it some other way. So what you're going to be doing then for homework are these other 4 problems related to inscribed circles. Have a great day.